If possible, we are going to find the sum for this infinite series. We have the sigma n from 1 to infinity, negative 3 in the parentheses, raised to the n minus 1 power, over 4 to the nth power. Notice that we have an n in the exponent here, and then we also have an n in the exponent here. The base here is negative 3, the base right here is 4. You kind of suspect this is going to be a geometry series, but then the problem is we have to write this so that it becomes some number inside raised to the n power. That way we will be sure that it is a geometry series, and then we will know what the common ratio is. Let's do some algebra. So I will just write this down again, the summation n from 1 to infinity. On the numerator, negative 3 raised to the n minus 1 power, we will break this apart as negative 3 to the n power times negative 3 raised to the negative 1 power. Because when we multiply, we can just combine the exponent. N plus negative 1, we just get n minus 1. So this is just a breakdown, right? And then we have over 4 to the nth power. And now, these two things, they both have the nth power. So I can write it like this. This is the summation, n from 1 to infinity. I can look at this as negative 3 over 4, and then everything inside raised to the nth power, okay? And then this right here, negative 3 in the parentheses raised to the negative 1. This is just a number. What's that number? Let's take a look. Negative 3 raised to a negative 1. Whenever we have the negative exponent, we bring this down to the denominator and then raise to the first power. So we have 1 over negative 3 to the first power, and which is just going to be 1 over negative 3. And this is just a number, negative 1 over 3. And I'll just put it right here, negative 1 over 3. This right here, in this form, we know that it is a geometry series because we have a number raised to the nth power. And we will be sure that this number, it's the common ratio, r, and then it's negative 3 over 4. As we can see, negative 3 over 4, the absolute value, okay, if you take the absolute value right here, just look at the absolute value, it is less than 1. Therefore, we know this series converges, and we can add them up. We can use the formula. So let's go ahead and do that. The formula is what? The first term divided by 1 minus the common ratio. So let's go ahead and write it down again. First term over 1 minus the common ratio, which is r. And now let's figure out what the first term is. For the first term, we plug in the starting n value into the formula here, and we will have negative 1 over 3 times negative 3 over 4 raised to the first power right here. Okay? And then over, this is a 3 by the way, and then over 1 minus the r. The r is negative 3 over 4. So we have negative 3 over 4, like that. And the rest is just computation. Look at the top, we have negative 3 over 4 to the first power, which is just negative 3 over 4. And then we have negative times negative, which is positive. And then the 3 and 3 cancel, and this and that cancel, positive, right? So we have just 1 over 4 on the numerator. On the denominator, this is 1 plus, right? Minus minus become plus. 1 plus 3 over 4. And 1 is like what? 1 is like 4 over 4. 4 over 4 plus 3 over 4, we have what? 7 over 4. This is a 7. And then you can see that we can multiply 4 on the top and bottom so that they cancel, 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 cancel. What's the answer? We have 1 on the top over 7 on the bottom. And therefore, this series right here converges to the fraction positive 1 over 7. This right here is it.